Sometimes we have to find the square root of a number that's not a perfect square, which means that we're not going to have an answer that's a whole number. However, we can use our perfect squares to help us estimate that value. So for example, to estimate the square root of 10 to the nearest tenth, we can identify the closest perfect square that is less than 10 and the closest perfect square that is greater than 10. Now, usually whenever I'm doing my estimations, it's easiest for me to come off to the side and to make a list of my perfect squares. Those are those numbers that there's a number that multiplies by itself to give us that number. So for example, I know 4 because 2 times 2 is 4, 9 because 3 times 3 is 9, 16 because 4 times 4 is 16. I mean, you can essentially just keep multiplying up. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64, and so on. That will help you whenever you're doing your estimations. So when we're looking at the square root of 10, I'm looking for numbers that are really close to 10. The closest number that is less, the perfect square, is going to be 9. The closest number that is greater, perfect square-wise, is going to be 16. Well, then we can take the square root of those numbers. The square root of 9 is 3. The square root of 16 is 4. That means that the answer for the square root of 10 is going to have to be between those two answers. The square root of 10 is going to have to be a number that's between 3 and 4. Well, then we can start essentially just guessing and checking. We can do 3.1 times itself, 3.2 times itself, et cetera, until we get closest to that number of 10, which is what they have done here. 3.1 times 3.1 is 9.61. 3.2 times 3.2 is 10.24. Well, 10.24 is closer to 10 than 9.61. So we can estimate our answer to be about 3.2 and then place it on a number line. So I'm going to come down here. Right here on number 9, all it's asking you to do is identify the two closest perfect squares, one greater than the radicand and one less than the radicand. So again, having that list of numbers is helpful. So on letter A, the square root of 8, I can come back to my list. The perfect square that is less is going to be 4. The perfect square that's greater is going to be 9. So I'm just going to come over here and I'm going to say the square root of 4 and the square root of 9. That's all it wants you to do on number 9. Okay, and then here it wants you to place their answers on the number line for your estimates. Well, I can give you a trick. Whenever we're doing our estimations, the number that is closest is going to help for your estimation. So for example, we know that our answer for letter A is going to have to be between 2 to 3 because the square root of 4 is 2 and the square root of 9 is 3. But look at these numbers. The number under the actual radical. Is 8 closer to 4 or closer to 9? It's definitely closer to 9. So our answer is going to be way closer to 3 than it is to 2. Okay? In other words, I don't want to be testing out 2.1 times 2.1. That's not going to work. That's going to keep our answer way closer to the square root of 4. So we're going to be wanting to stay closer to the square root of 9. So we're going to be doing numbers like maybe 2.8 or 2.9 to help us find our estimate. But you'll be using your digital calculator to help you come up with those numbers for your estimates and then placing them here on the number line. If you have a writing tool like I do, like I said, you can just write on the Kami. If you do not have a writing tool, you can use the text box and you can type here. You can even just put square root of and your numbers if it's hard for you to get a radical drawn.